Welcome, ladies and gentlemen. Today we are going to pick up talking about classification. And this is going to kind of wrap up our section on evolution by looking at where do these organisms really fit into each other? How do we classify them both based on how they look, but also now really taking into the context of their evolutionary history? So when we're looking at evolutionary relationships and how we connect the classification of organisms to that evolutionary history, there's a handful of terms to know. We're going to walk through these as we continue this section. So just be aware of these terms, make note of them when they show up. They're really going to help to drive home your understanding of this particular section. So we'll talk a little bit about taxonomy, binomial nomenclature, how that fits in, the idea of cladistics and creating cladograms using derived characters, what a phylogeny is, how molecular systematics fits into then the creation of phylogenetic trees. So all of these terms are going to show up as we go. So let's kind of get started and walk through them. So first and foremost, taxonomy is just the science of grouping things according to similar characteristics. I would assume most of you probably at this point have learned your basic hierarchy of classification. So the kingdom, the phylum, the class, order, family, genus, and then species. We're also going to throw in the domain. That's going to go up and above that. So really it's domain, and then kingdom, phylum, class, order, family, genus, species fits within that. And most of you have probably learned that hierarchy somewhere along the way. Make sure you know them because that is going to come up. So the kingdom to species classification was originally introduced by Carlos Linnaeus, and we mentioned him as being one of those influencers for Darwin. He was sort of predated Darwin, but he was really the one to sort of suggest that if we looked at organisms, we could start piecing them together, putting them together in categories, and as a result, be able to come up with some commonalities, common language to be able to discuss those species. So, regardless of what your spoken language was, whether it was English, German, French, Spanish, um, we could create these classifications that would be common among all languages. So he's really the one who developed the idea of binomial nomenclature. So when we literally break that down, bi means two, nomial is name, nomen is name, and clature is system. So it's a two-name naming system. That's exactly how those roots come in. And this is what we talk about when we talk about an organism's scientific name, or we use those two most specific classification levels, the genus and the species, to do this. And most of these are derived from Latin roots. That was sort of how Linnaeus decided to create that common language, scientific language, when he was developing the system. So a lot of things have Latin roots, and hence why we're learning all those Latin roots this year. Um, so when we look at scientific names, we look at something like Canis lupus for a dog, Homo sapien for human. You have that genus here, species here. Typically, when we type these, just sort of convention, these technically should be italicized because those common names are typed, and if you see them in handwritten text, then they should be underlined. Genus is always capitalized, and species is always lowercase. Now, here's the thing. When Linnaeus was developing this system, they had no idea what DNA was. They had no idea how physical traits um, were biologically, molecularly passed on, how they were expressed. They had no idea about DNA, proteins, the whole nine yards. They didn't understand genetics. They knew that characteristics got passed from parent to offspring. They could see that, but they had no idea what the mechanism was to do it. So that meant that Linnaeus created this classification system simply based on physical characteristics. If I looked at an organism and looked at their characteristics, how were they similar? Um, and then they may have also taken into consideration where they lived, roles they might have been able to observe they were playing in their environment, and that sort of thing. So it was all based on physical observations. And as a result, that definitely then in turn meant that some of the common names for organisms were not really based in anything other than physical looks or physical location. And so, as we started diving into the DNA and the RNA and the proteins and the molecular information, we're finding that a lot of classification schemes, um, especially those common names, are kind of misleading. They're not really actually related to each other evolutionarily, at least not closely related. So, something like our cute little red panda here in the middle, based on that common name, you would assume that that red panda must be closely related to something like the giant panda. And yet, they're not. In fact, they're much more closely related to raccoons. Um, and again, if you kind of look at them closely, you start to see some of those physical similarities, but that's where we had to be careful with those classification schemes, those common names, and ensuring that we are developing systems that not only reflect physical observations and physical characteristics, but that also are true to evolutionary history. And so that has meant that a lot of species, as we've gotten better with the molecular data, have had to get rearranged and reclassified, potentially even renamed because we've learned more information recently based on their molecular information that they may not have been as closely related to each other as we initially thought.